problem described involves a range not heating up due to unusual voltage readings at the terminals. The readings are to ground 220 volts, A to B 220 volts, and neutral to be nothing, which contrasts with the normal readings of A to B 220 volts, A to ground 120 volts, and B to ground 120 volts when the range is unplugged. The root cause is identified as the neutral not being properly bonded to the case at the service. This leads to a phenomenon called backfeeding through the chassis. To understand the issue, it's crucial to grasp how a 3-wire electrical system works. In a typical 3-wire 240/120 volt system, there are 2 hot wires, often labeled A and B, a neutral wire, and a ground wire. The voltage between the 2 hot wires A and B is normally 240 volts. The voltage from either hot wire to the neutral is normally 120 volts. The ground wire is intended as a safety conductor, providing a low impedance path back to the source in case of a fault. When the neutral is not properly bonded to the case at the service, several things happen. Firstly, the neutral loses its reference point. The neutral should be at or very near 0 volts relative to ground. Without the bond, the neutral voltage can float. Secondly, any current that would normally flow through the neutral wire starts looking for alternative paths back to the source. This is where backfeeding comes into play. The current finds its way back through the chassis of the appliance and any other grounded conductive parts. The 220 volts applied to the neutral results in 220 volts appearing on the ground. This elevated voltage on the ground is dangerous and explains the technician's unusual voltage readings. The path of current is firstly from the ungrounded conductor to the load. Secondly, without a proper neutral bond, the return current flows through the appliance chassis and ground conductor. Thirdly, this current elevates the ground potential to 220 volts. To resolve this issue, the first step is to verify that the neutral is properly bonded to the case at the service entrance. This is typically done inside the main electrical panel. The neutral conductor should be connected to the grounding electrode conductor, which in turn is connected to a grounding electrode such as a ground rod or a metal water pipe. To properly troubleshoot this problem, one must employ a systematic approach that addresses safety concerns, voltage measurements, circuit integrity, and load testing. The first step is to prioritize safety. Before commencing any electrical work, de-energize the circuit. Turn off the breaker that supplies power to the range at the main electrical panel. Verify that the power is off by using a non-contact voltage tester or multimeter to check for voltage at the range outlet. Lockout and tag-out procedures should be followed to ensure that the circuit remains de-energized while work is in progress. Wear appropriate personal protective equipment, including safety glasses and insulated gloves. The second step is to visually inspect the range outlet and the range cord for any signs of damage, such as burnt wires, loose connections, or corrosion. If any damage is found, replace the damaged components. Check the grounding conductor's continuity from the outlet to the main electrical panel. This ensures that a proper ground path is available. The third step is to measure voltage at the range outlet with the range unplugged. Use a calibrated multimeter to measure the voltage between the following points. Firstly, measure between conductor A and conductor B. This should read approximately 220 to 240 volts. Secondly, measure between conductor A and the grounding terminal. This should read approximately 120 volts. Thirdly, measure between conductor B and the grounding terminal. This should read approximately 120 volts. Fourthly, measure between the neutral terminal and the grounding terminal. This should read as close to 0 volts as possible. A significant voltage reading between the neutral and ground indicates a problem with the neutral bond at the service panel. The fourth step is to examine the main electrical panel. Remove the panel cover to inspect the wiring. Be extremely cautious when working inside the panel, as live circuits are present. Verify that the neutral busbar is securely bonded to the panel enclosure and that the grounding electrode conductor is properly connected to the neutral busbar. Look for any loose connections, corrosion, or damage to the wiring. Tighten any loose connections and replace any damaged components. The fifth step is to perform a neutral bond test. Use a multimeter to measure the resistance between the neutral busbar and the panel enclosure. The resistance should be very low, ideally less than 1 ohm. A high resistance reading indicates a poor or missing neutral bond. Also, inspect the grounding electrode conductor's connection to the grounding electrode, ensuring that it is secure and free from corrosion. The sixth step is to load test the circuit. Plug the range back into the outlet and turn it on. Use an amp clamp meter to measure the current flowing through each conductor R and B. The current should be balanced between the two conductors. If the current is significantly different, it may indicate an imbalance in the range's heating elements. Also, monitor the voltage at the range outlet while the range is operating. The voltage should remain stable and within the acceptable range of 220 to 240 volts. The seventh step involves checking the range's internal wiring. If the voltage and current measurements at the outlet are within normal ranges, the problem may be inside the range itself. Disconnect the power to the range and remove the access panels to inspect the internal wiring. Look for any loose connections, burnt wires, or damaged heating elements. Use a multimeter to test the continuity of the heating elements. Replace any faulty components. The eighth step includes checking the breaker. Ensure that the breaker supplying power to the range is the correct size and type. A breaker that is too small may trip frequently, while a breaker that is too large may not provide adequate protection against overcurrents. Test the breaker by using a breaker tester or by manually tripping and resetting it. Replace the breaker if it is faulty. The ninth step involves inspecting the service entrance. If the problem persists after checking all the above components, the issue may be at the service entrance. Contact a qualified electrician to inspect the service entrance, including the service drop, meter, and main disconnect. Look for any signs of damage, corrosion, or loose connections. The 10th step is documentation. Keep a detailed record of all tests, measurements, and repairs performed during the troubleshooting process. This documentation will be helpful for future reference and for warranty claims if necessary. The absence of a proper neutral bond at the service is a dangerous situation that can lead to electrical shock hazards and equipment damage. It's crucial to address this issue promptly and correctly. If you are not comfortable working with electricity, always consult a qualified electrician. In this specific case, correcting the neutral bond at the service should resolve the range voltage issue and allow the range to operate normally. After verifying and correcting the neutral bond, recheck the voltage readings at the range outlet with the range unplugged. You should now see approximately 240 volts between A and B, approximately 120 volts between A and ground, and approximately 120 volts between B and ground. The voltage between neutral and ground should be close to 0 volts. With the range plugged in and operating, monitor the voltage to ensure it remains stable. It is also important to understand the potential dangers of a floating neutral. A floating neutral can cause appliances to experience overvoltage or undervoltage conditions, leading to damage. In some cases, it can also create a shock hazard, as the grounded parts of appliances may become energized. For example, if a 120-volt appliance is connected to a circuit with a floating neutral, it may receive more or less than 120 volts, potentially damaging the appliance. The NEC or National Electrical Code provides specific requirements for grounding and bonding in electrical systems. These requirements are designed to ensure the safety of people and property. It is important to follow the NEC guidelines when installing or modifying electrical systems. Some relevant NEC sections include Article 250, which covers grounding and bonding requirements. Section 250.24 specifically addresses grounding of service-supplied alternating current systems. Section 250.50 covers grounding electrode systems. Section 250.166 covers sizing the grounding electrode conductor for alternating current systems. These sections detail how to properly bond the neutral to ground at the service entrance and the requirements for grounding electrodes. In addition to the neutral bond, other factors can contribute to voltage problems in electrical systems. These include undersized wiring, loose connections, and faulty equipment. It is important to address these issues as well to ensure the proper operation of electrical systems. Undersized wiring can cause voltage drop, leading to dimming lights and reduced appliance performance. Loose connections can create heat and increase the risk of fire. Faulty equipment can draw excessive current and overload the circuit. In summary, troubleshooting a range voltage problem requires a systematic approach, a thorough understanding of electrical principles, and adherence to safety precautions. The key is to identify the root cause of the problem and take corrective action to restore the electrical system to its normal operating condition. In the case of a 3-wire system with unusual voltage readings, the most likely cause is a missing or improper neutral bond at the service. Correcting this issue should resolve the problem and ensure the safe and reliable operation of the electrical system.